Hi students, welcome to Earth and Environmental Science and Module 6 on hazards. This is video number 5. We're going to specifically look at lahars and also just a quick comment on some of the poisonous gases associated with volcanic eruptions. This is the follow-on from our previous video where we were looking at ash flows and also at lava flow. And so these are the other two hazards associated with volcanoes that we want to have a look at: poisonous gas emissions and lahars. And lahars is probably a new word or one that you may not be as familiar with, so I'll spend a little bit more time focusing on what lahars are and also direct you to a little activity you might like to have a look at back either in the classroom or at home. So firstly, we want to make sure that you know what a lahar is. We want you to be able to contrast lahars and gas emissions associated with volcanic activity, and especially looking at the different types of environments or eruptions which may be associated with each of these, and also to explain several identified hazards associated with volcanic eruptions. So we hopefully will now have a little catalogue of 4 at the end of this video that will include ash clouds, lava flows, lahars, and poisonous gas. So just to recap from our previous video, we had 2 that we looked at: the lava flows, which were very hot but often very slow. And the speed of those lava flows was proportional to the temperature, so higher temperatures and you had greater speeds, but inversely proportional to the silica content. So high silica content creates more viscous lava and therefore more resistance to flow. One of the problems associated with lava flows is that whilst you can get relatively close to them, they're incredibly hot and they can take a long time to cool down. By contrast, ash clouds and ash flows can be highly destructive. They can get into the atmosphere and affect weather and climate patterns, and that basically the difference I'm looking at there is whether they're local or more global in terms of their impact. We certainly think that there may have been some volcanic eruptions which may have been linked to some of the extinction events in the past geological history of time. So we know that volcanic activity, especially ash clouds, can have devastating impacts on the climate and therefore on the biosphere as well. But they can also be very destructive right at the site. So the fact that they are influenced by gravity means that pyroclastic flow can fall under gravity back down to the ground and sometimes reach great speeds depending on the local topography, because if it's very steep, if the sides of the volcano are quite steep, which they are likely to be for one of these cinder cones, for one of these pyroclastic eruptions, then you are likely to have very fast moving material accelerated by gravity and therefore potentially creating a huge amount of devastation in its wake. We know too that the devastation caused by the recent ash flows in Tonga were an example, a very sad example of this kind of destruction that can happen as a result of volcanic eruptions. But there are 2 other things that we wanted to have a little bit of a look at in terms of the hazards associated with volcanic activity. And the first of these is lahars. And one of the things with lahars is that their impact can be short-term but also long-term. What are lahars? Well, lahars are just a mixture of volcanic ash, rock, and water. Often rain can be associated. You may have seen a couple of the videos going around and some imagery of certainly lightning associated with volcanic eruptions. And we can also have rain. We can also have water that's washing down this volcanic ash, creating a mud, and also bringing with it rock fragments. And as they flow downhill, they've obviously got a lot of mass, they've got a lot of weight behind them, and this can create some quite severe erosion. So you get some significant effects of erosion as a result of this material that's basically going through and gouging into the landscape. The problem, of course, too, is that it can solidify, and if it does, it forms a kind of a concrete, which is not very good for plant growth, for example, and it can create quite significant problems. The other thing that can happen, I guess, before that happens, or it can happen in association, I guess, is when you get rainfall. And one of the problems that was experienced by the people in the Philippines is they were still experiencing the effect of lahars many years after the original eruption of Mount Pinatubo. That's an area where you get a lot of monsoon rains, so very heavy rains. They would be picking up all of that material that had been deposited as part of the lahar, and or at least as part of the volcanic eruption, and then creating these mud flows basically associated with all of this volcanic activity mixed with the water that was then rushing down the mountainside. So you get this problem associated with lahars in that when you get this deposition of ash deposits, water that comes along later on can just stir it all up, pick it all up, and transport it often from the higher areas down into the lowlands. Now, the other thing that we associate with volcanic activity is poisonous gases, and I briefly mentioned this too in the previous video. And what we want to look at is some of these key gases. So carbon dioxide and water are probably the two most common ones. You can see steam almost always coming out of these volcanic vents. And so water is obviously one of those important gases that's produced. We also know that water is a very significant greenhouse gas. It's got obviously a much better PR department because it doesn't get the same rap as carbon dioxide or methane, for example. But water is a very significant greenhouse gas, and it's a concern if its concentration in the atmosphere rises. We just know how uncomfortable it is when the humidity levels are very, very high and there's a lot of water in the atmosphere. But it also has an impact on global warming. The release of water and carbon dioxide is one thing, but we also may find carbon monoxide or sulfur dioxide or sulfur trioxide and hydrogen chloride, and you'd be probably aware of some of these in their interactions with water producing quite strong acids. And acids are a real problem, especially acids that are associated with things like the sulfur oxides or hydrogen chloride, because we're talking hydrochloric acid, we're talking sulfuric or sulfurous acid. These are significant concerns. They drop the pH of rain very significantly, and they can cause significant damage to plants and also to human buildings and things like that, as well as, of course, being very irritating if you happen to be out and getting this rain on your skin. So poisonous gases can be respiratory irritants as well, so they can have an impact on our respiratory surfaces. They can be irritating. Obviously, our respiratory surfaces are moist as well, so it means that if you breathe in these gases, it's likely that you're going to create these little chemical processes within your own mucous membranes, and that can, of course, again, create some quite irritating and disabling effects in your respiratory systems. So these are some of the general ideas around the different hazards associated with volcanic eruptions. You'll find a couple of little advertisements, I guess, at the end of some of these videos. The Australian Earth Science Education website has some absolutely fantastic material, lots of really great resources to help support you in your study of earth and environmental science, and also lots of very simple activities. One of the things which is a modified activity from a US geological organization is the lahar in a jar. And you'll see on the video some ways in which not only can we demonstrate different types of lahars based on different consistencies, different amounts of water, but also a simulation of what happens once the lahar's formed and maybe has had a chance to sort of solidify and settle, and then what happens after maybe we get some rainfall associated with just this regeneration of lahars and what can happen to that material as it moves down slope. So it's definitely worth visiting the Australian Science Education website, having a look at a lot of the material that they have there, and perhaps trying a couple of these simulations yourself. We will obviously carry some of these out in the science laboratory, but with our slight rearranged timetable conditions this year, that is probably going to restrict us in some ways. But definitely something that you can have a look at at home. Thanks very much for watching.